My name is Neema and I'm taking Stochastic Calculus, and this video is to explain how to solve a question from our CBT using Excel. So I'm going to solve two questions, and let's start. I'm going to solve question 3 and question 7. So let's start with question 7. So Tamara Mellon, a London-based fashion designer, is expected to receive 100 million yen from a Japanese company as payment for goods sold in 1 year. Concerned about potential exchange rate fluctuations, the company decides to hedge its currency risk by purchasing an option that grants the right to exchange yen for pounds at a rate of 0.005 pounds per yen. Given the following information, so the following is what we're going to use to solve the question. The first information given is that the spot exchange rate is 0.005 yen, euros per yen. The second is that the volatility of exchange rate between the two currencies is 0.08, and the continuously compounded risk-free interest rate for yens is 0.055, and the continuous risk-free interest rate for pounds is 0.05. So we are required to calculate the cost of hedging using 12-period binomial tree and using two distinct approaches. One is pound denominated and the second one is yen denominated. So this is how we're going to solve it using Excel. So this is my question, is how I solved it. So first is that I listed the data that I was given from the question in this table here, whereby the spot rate, since this is pound denominated, so the domestic interest rate will be our euro, the interest rate for the pounds, so 0.035. And also the interest rate for the foreign risk-free rate is R yen, which is 0.055, and the periods we're given is 12. And lastly, the stock price volatility at 0.008. So the first thing, we're going to calculate the upper factor, which is U. And to calculate U, we're going to use this formula, which is E power the risk-free rate for the domestic minus the risk-free rate for the foreign times H plus sigma times the square root of H. So this is how I solved for the upper factor, which is this value. And then also we are going to calculate the value of D, which is the down factor. Calculating the value of D is the exponent A power RD minus RF bracket H minus sigma H. The only difference between these two is the symbol here. The first is for upper, we're going to add, and then for the down factor, we're going to minus it. So this is the value here, and this is the formula that I used. And then that is what I got for my value of D. And then also we're going to find the value of P star, and that is calculated by using this formula, which is E power of RD minus RF bracket H minus D, the whole thing divided by U minus D. So this is how I solved it. There's all our values, and then that's the value I got. And also I had to find the value of 1 minus P star, which is just 1 minus this value here. Equals to that. After that, we're going to go to our binomial tree. So since we're given the period is 12, so we're going to create this table from 0 to 12, from time equals to 0 to time equals to 12. So as it's going to be the period out of the number of periods given. So I just did for one cell and then dragged towards the end. to get the values of all the other cells. Then we're gonna start with the exchange rate table. So for the exchange rate at time zero, we have our exchange rate as 0.005 that we are given. To get this value here, we have this formula in the cell. So it says that we have to take F4, multiply it with the down factor, and also the F5, multiply it with the upper factor. So that's the formula I used. I used this and then I dragged it through the whole row to get the values of exchange rates. After that, I'm gonna find my put values. My put values, first of all, this is a put option because since we have our pounds as the domestic currency and we want yens, so we're gonna have to sell our pounds to get yen. So that's a put option. So that's why after getting the exchange rate, I also calculated for the put prices. So to calculate the put prices, we have to work backwards from this side. So since we have the first table, which is the exchange rate, to get the put prices, we're gonna take the values we get from the subtraction of the K, the strike price, minus the exchange rate prices. Yeah, so we're gonna use this formula. So anything that's lesser than zero will turn back to zero. So I did that and it jumped through here. And then after that, after getting this first column, I solved for all this. Since we can solve the the for the put prices without getting the last column first. So to get these other values, I used this formula, which is if this cell below is empty, then then it will remain empty. But if it's not, then the cell above you multiply it with the risk-free rate of the domestic interest domestic currency plus the 1 minus p star, multiply it with the lower cell, and this whole thing multiply it to the exponential of negative r h. That's how you're gonna solve for the put price here. Then you're gonna drag this through all the cells to get the values of p. And after that, this first value is our put price. After that, I saw for yen denominated, whereby if for yen denominated, it's more of a call option because this time yen is your domestic currency and you want to get pounds. So you're gonna buy yens to get pounds. So that's a call option. And and this is the value of stock exchange rate for your yen. Since from here you're given 0.005 euros per yen, but this time you want to find the value of yens per euro. So it's just this value up here, just the reciprocal of this value. So 1 out of C3, you're going to get this value, the spot exchange rate for yen denominated currency. And for your strike price, you're going to do the same thing. That's going to be 1 out of this, 1 out of C4 to get the strike price for yen denominated currency. So all this data will remain the same except for this part whereby the risk interest rate for the domestic now will change to BR yen, which is 0.055, and then for the foreign will now be 0.035. So that means the values of upper factor and down factors will also change. And apart from that, we also have to find the values of P star and 1 minus P star. And yeah, so again, as the previous table, as how we did when we prepared the table, we're gonna do it the same here. We're gonna calculate the the exchange rate prices here. Since we have this, we have our initial use of our call price. And calculating the value of call price, it's we have to take the the exchange rate prices minus the strike prices, and anything lower than zero will return as zero. So this last column here. So I just solved for this last column first, and then later I also applied a formula. Yeah, the same one that we use for my put price. I paste it here and then drag through these cells to get the values of the call price. And then after that, it's little to calculate the cost of hedging for each. For the pound denominated or the put option is just the put price multiplied with the number price of put. And for the case of yen denominated, we're going to take the same value, which is 100 million times the call price, but divided by the strike price to get the cost of hedging. Now that is 7A. Let's go to 7B. Solving for the question 7B. 7B is you're required to calculate the price of an option by conducting a Monte Carlo simulation of 100,000 iterations using Microsoft Excel. For this task, assume that the Black-Scholes framework is applied to the currency exchange rate. So this is how we're going to solve using Excel. So first of all, let's list down the data that we have. This formula to get 100,000 cells, like rows. Yeah, so this formula, I got the rows. And then after that, I calculated for the random variables, which is equal to rand bracket, and then I get these values, the random variables. After that, I solved for the z-score values of probabilities here to get this new values, which are the z-score values. After that, I had to find the exchange rate using this formula, which is xt equals to x naught e to the power re minus ry minus 0.5 sigma square bracket t minus sigma w root of t. So I use re minus ry since I'm using the pound denominated, and for pound denominated is re is r pounds is the domestic currency rate. So I'm going to use domestic minus the foreign one. So 0.035 minus 0.055 to solve for our exchange rates. So we are given the question that our x naught is 0.05. To get the exchange rate. So after that, after just calculating the first cells, they can just tap here, double tap here, and then get the values of all other cells. After that, getting to find the payoff value is just the payoff value. Since this is put option, you're gonna take the strike price minus the exchange rates. So I took the strike price minus the exchange rate to get the payoff. So anything below zero will be zero. Like yeah, will be zero. After that, I calculated for expected payoff, which is just the average of the payoff, and then average of this one. And then for the price of the put option, I took the expected payoff times e to the power negative r e times t times the 100 million to get this value as the price of the put option. So that's our question 7. So let's do question 3. This is the question. 3, you're told Berry purchases a European put option on a LGX Madrid stock with the strike price of 36.5 and maturity date of 60 days. Berry immediately Gamma hedges his position. He dynamically adjusts his portfolio by acquiring shares of the stock and at the money European call option with a 60-year maturity. Berry ensures that the net amount invested in a portfolio remains zero by using a risk-free bond. The information of the LGX Madrid stock are as follows. So you're given a current stock price of as 35, your volatility is 28%, the continuous dividend yield is 4%, continuous risk-free rate is 6%. And also that Berry hedges his position daily on the stock price movement. Calculate the detailed profit or loss for each day over a 27-day period, considering the stock prices movement provided in the accompanying table. So given the stock prices for the 27 days, and finally determine the total profit Berry accumulates over the 27-day period. So task here is to calculate the total profit Berry accumulates. So this first two tables are the tables from representing the data I got from the question. So the first is the European put option. In the European put option, I was given the strike price of 36.5 and the stock price of 35. Time to maturity will be 60 out of 365 since it's always in years, and our time interval, since we're told that it's done daily, so it's gonna be 1 out of 1 out of 365. And lastly, this other table here is for European call option at the money. So for this case, the strike price and the stock price will be the same, 34, 35. Number of days the same, which is 60 days. Risk-free rate, all this data is the same as the first table. So these are the formulas that we're going to use to create this table. And to calculate a profit or loss, there's three components that are considered. The first is derivative component, the second is stock component, and the last is cash component. So let's start with the derivative component. So for the derivative component, we have two parts. So we have a put option, and we also have the call option. So from my table here, I listed the number of days, which is 0 to 27. And I also had this from the question. I had the stock prices too from the question. And this, the value of T to T minus T, I got it from the taking time to maturity minus the small t, which is time to maturity is 60 out of 365 minus the t here out of 365 since they're all in days. So I did that. After calculating the first cell, I just dragged down to the rest to calculate through the rest. This I was given the stock price. Now the change in stock price is calculated by taking cell minus this cell minus this cell. So it's S1 minus S0. That's why the first cell we have nothing. So the first change is going to be seen here, which is 0.5, negative 0.13. So this is the formula. I took this cell minus that cell. So coming to the put option, whereby we have to calculate the value of D1, D2, N minus D1, N minus D2 to get the put price. So here is the formula to calculate your D1. D1 equals to ln of ST out of K plus R minus delta minus 0.5 sigma square bracket T minus T. The whole thing divided by sigma bracket T minus T. How I calculated for D1. So after calculating the first cell, I also drag it down to get the rest. For D2, the formula for D2 is using the result from D1. You're going to take D1 minus sigma bracket T minus T. So after that, I calculated for N minus D1 and N minus D2. Put price. To calculate the put price, I have to use this formula here, which is K power E minus RT N bracket negative D2 minus ST E power negative delta T N minus D1. That's how I calculated for my put prices. I just did for one cell and then dragged down for all the other cells. And then after that, I calculated my delta put. My delta put, I can calculate it using this formula, which is negative E to the power negative delta bracket T minus T bracket times N minus D1. So I have this N D1 here. I have T minus T. I also have my delta, and that's how I'm gonna solve for my P. That's gamma put. I'm gonna calculate gamma put using this formula, which is e power negative delta bracket t minus t times e power negative 0.5 d1 squared out of st times sigma times the square root of t minus t times the square root of 2 pi. So that's how I got the gamma put values. That is what I used to get the gamma put values. After that, after getting this all, I could now calculate the change in put price. But the change in put price is the PT minus PT minus 1. So I took this value below minus the one above, the value below minus the value above to get the change in price. So that's the first part of the derivative component. Coming to the call option. So for the call option, we also have to calculate the value of D1, D2, ND1, and ND2, the same way as we did for the put price. So coming here to calculate the call price, the call price is calculated using this formula, whereby it's stock price times exponential negative delta t ND1 minus ke negative RT ND2. That's how I got my coal prices. That's how I got my coal prices. After getting my coal prices, I calculated for my delta coal, delta coal, which is exponential to the power negative delta bracket t minus t and d1. I had to calculate for gamma call. Gamma call is same formula as gamma put, which is this formula here. So it's the same as this. I calculated for my gamma call and got this values here. So for call option, to get your change in call price, we have to have this value here, N1 values. So I also calculated the values of N1 values. The N1 values can be got back. So N1 equals to negative gamma put out of gamma call. That's how I got N1 values. Then after getting my N1 values, I could calculate the change in call price, whereby it's equals to N1 times your change in call price now, which is CT minus CT minus 1. So here it's N how you calculate your change in call price. And then now that's all for the derivative component, whereby we've seen these prices, the call prices are all positive, which means this is a long position for uh, put option. And the call prices are all positive too, which means this is a short position for call option. And now we can calculate for our stock component. Our N2 values. Our N2 values can be calculated using this formula here, which is negative change in negative delta P plus N1 times delta C, delta call. Get into. So you're gonna do that and drag down for all the values of N2. And for the stock price price. This is the formula to get the stock price. We're going to use the N2. So it's N2 times ST times E power delta H minus ST minus 1. So this is how you get the stock price here. So this N2 times your J7, which is your S0 times the exponent to the power 0.04 times your H minus your S1. So that's how I got my stock price, my stock here. After that's we're done for the stock component. Now the last part, which is our cash component. Calculating the cash component, you have the values of should have the value of V and your money. So V equals to E plus N1 C plus N2 S. So this is the formula for V. That's the formula. To get your money values, we're gonna have to use the values of V. So it's gonna be negative V bracket E power RH minus 1. That's how I'm getting the values of my money here, the money column. Then lastly, we can calculate, since we have all these columns now we can calculate the daily profit or loss. The daily profit or loss is the summation of change in put option plus change in call option plus the stock and plus the money. You get your profit or loss. So this is the values of our daily profit and losses. And since the question wanted the accumulated profit and loss, so this is the summation of this last column here. So that's it for my video, for my presentation. And I hope you've understood the main points. Thank you.